Okay. Good morning, students. Welcome to online classes, Shekhar Gulkul, IIT JEE Academy. Right, today we are going to continue formula framing of ionic compounds. Yesterday, last 5 minutes, due to some mic problem, so you are not getting proper sound. So first, let me explain whatever I taught in last class. So I will continue 5 minutes. So after completion of 5 minutes, then I will continue today's session. Okay, right. So yesterday, what I taught, continuation of cations and their names. Right, continuation of cations and their names. Let me continue. Here name of here cation. So cation, name of cation and its symbol. Then lastly, what I give here, phosphonium ion. Phosphonium ion. So here its name is what? Phosphonium ion. Phosphonium ion. And later I give example methyl and OH2. This is said to be oxonium. This is said to be oxonium ion. So right here, what is the meaning of oxonium ion? Oxonium ion means, so whenever there is a positive charge on the oxygen, is said to be what? Normally oxonium ion. So here oxygen having positive charge, phosphorus having positive charge is said to be phosphonium ion, and nitrogen, if it is having positive charge, is said to be what? Ammonium in case of ammonia. Normally ozonium ion means nitrogen positive, ozonium ion. Right, this is what oxonium ion. So up to this I taught. Later I think these are what ions will be given: phosphorus plus 5 and phosphorus plus 3, and if you have nitrogen, nitrogen plus 3 and nitrogen plus 5, and these ions not exist. Okay, not exist in free state. In free state. This is what I taught, I think. Right, here P plus 5 and P plus 3 and nitrogen plus 3 and nitrogen plus 5. So these ions name, normally you can write it, you can call it phosphorus, but here getting these free ions very difficult. Why? Because these are what? Non-metal ions. So being a non-metal ion, so having positive charge in free state, in elemental free state. So on element, if you have the positive charge, this is very difficult. That means you need to remove 3 electrons. Here you have to remove 5 electrons. Here you have to remove 3 electrons. Here you have to remove 5 electrons. So removal of electrons from non-metals very difficult. Why? Because if you see the periodic table, so from left to right, size of elements decreases. When size decreases, obviously nuclear attraction increases. Due to this nuclear attraction, it's very difficult to lose and to get free ions. But you will get these charges in combined state. You will get. Getting charges in combined state is said to be what? Oxidation state. So here phosphorus will exhibit plus 3 oxidation state, phosphorus will exhibit plus 5 oxidation state, and nitrogen will exhibit plus 3 oxidation state, and nitrogen will exhibit plus 5 oxidation state. These are what? Oxidation states will exist, but not free states. This is what I taught in last class, and after this I gave a note point. Note, what I gave note? According to note. So here boron plus 3, and here you can take it carbon plus 4 and nitrogen plus 5, nitrogen plus 3 and oxygen plus 2 and phosphorus plus 3 and plus phosphorus plus 5. So these type of ions, it's very difficult. You cannot get not in free states. Not in free states. Free state. So getting what this type of ions getting in free state is not possible. So not in free state. So they will means this type of all ions you will get in combined state, combined state in covalent compounds, in covalently bonded molecules, in covalently bonded molecules. This is what you can say that this is what covalently. In case of covalently bonded case, you will get what? +3 oxidation state of boron and +4 oxidation state of carbon and +5 and +3 oxidation state of nitrogen and oxygen +2 and phosphorus +3 and +5. You will get in combined state when compound is covalent nature. You can't get free ions like iron +3 will be there. For example, here we are taking iron +2 and here iron +3 and sodium +1 and magnesium +2 and aluminum +3. These are all will exist in free states. In free state, right here you need to remember one thing, getting free state is different and getting charge on the atom in the combined state is different. So getting charge on atom in combined state is said to be oxidation state. Oxidation state. This is said to be charge on the metal is equal to oxidation state of this metal. So always oxidation state is not equal to charge on the metal. So in the free state only, these are the what ions, mostly S block elements and D block elements will give the ions in the free state. Then they will exist and they will be stable in free state form. But not in case of non-metals like P block elements, especially P block elements. So boron, carbon, nitrogen, oxygen and phosphorus, these are what? Smaller atoms. They are smaller atoms. These smaller atoms will exhibit charges in combined state. Combined state is said to be what? In covalent bonded molecule only. You will get these are the charges. This is what I taught in last 5 minutes. Right. So this is what next you can note it and you can note down explanation if you are feeling any extra information in today's session, so you can add it. Right. So in last class we started what? Naming of ions, cations, especially cations. Right. Why we are discussing naming of cations? And to write the formula of ionic compounds. To write formula of ionic compounds, we need to know the name of cation, name of anion. So when you know the name of cation and the name of anion, then easily you can write a resultant formula of the ionic compound. So for that you should know the what are the ions, cations and what are the anions and their names. Once you learn all name of cations and anions, then it will be very easy. Next, in last class, most of the cations will be ended with IUM name, and there are some ions. They are not ended with IUM. Example, if you take example, zinc is there. So zinc positive or neutral, it will be zinc only. Next, iron +2 and +3. There is no IUM. Iron +2 means ferrous. Iron +3 means ferric. Next, same way copper +2, copper +1. Copper +2 is what? Cupric. Copper +1 is cuprous. Same way mercury. Mercury +2 is mercuric and mercury +1 is mercurous. And tin +2 is what? Stannous. Tin +4 is stannic. Lead +2 oxidation is plumbous. Lead +4 oxidation state is plumbic. So these are what means names of ions, but in this there is no IUM. Okay, don't think it always positive charge means IUM, not there are some ions. That what only I taught in last end. Okay, last end 5 minutes. This is what I revised. Right. Now today, after knowing cations, now you need to know the naming of anions. Naming of anion. Then anion, formula of the anion and its name. Here now today's session is naming of anions. After knowing naming of anions, then we will write the ionic compound formula. Right. So anions means what? Negative charge particles, means negative charge. There must be a negative charge on the species. Right. First let me take simple ions. Normally halide ions. This is what? Fluoride. F minus is fluoride. Normally when you will get anions, means how we will get anions? When there will be an addition of electron. When we are adding electron, means gaining of electron will gives anions. Gaining of electron means reduction. Always you need to remember, from the neutral atom, if you get negative charge species, is said to be what? Reduction reaction. That whatever the reaction is said to be reduction. On reduction of non-metals, especially non-metals will exhibit negative charges. On reduction of non-metals means most of the p block elements. The p block elements will give what? Anions. Now list of anions I will give. After that we will name the naming of anions. Right here F minus is what? Fluoride ion, and Cl minus is what? Chloride ion, and next Br minus, bromide ion, and next I minus means iodide. These are what? Halogen anions. Next after that oxygen anions, OH minus means hydroxide, like sodium hydroxide, aluminum hydroxide. You are getting what? This is what? Hydroxide ion. Right, one thing, let me take it most of the anions common name end with what? Here ide. Please you can notice ide, R8. Right, these are the name of anions, names end with ide. Fluoride, chloride, bromide, iodide, hydroxide, like that. Some other names like ite, sulfite, chlorite, okay, 8, sulfate, nitrate, okay, bromate, like that you will get 8. So these are the suffix of name of anion. Suffix means end name. Right, please this is what general identification of anion is what? Ide, 8, ite. Right, OH minus. Next if oxygen is having -2 charge, this is what said to be oxide, O minus 2, oxide. Next here O2 minus 2, this is peroxide, and next O2 minus 1, this is superoxide, this is superoxide. Here oxide means what? On one oxygen there is a -2 charge. Here on two oxygens there is -2. Means with respect to one oxygen, what will get here? Charge. With respect to one oxygen, here O -1 and -1. This is what? Peroxide. This is what combinedly we are writing O2 minus 2 is peroxide. Sodium peroxide, barium peroxide. Okay, like that you will be having the peroxides. Next this is superoxide. This is what? Superoxide. In the superoxide there are two oxygens. On each oxygen charge will be how much here? So charge will be what? How much? Here minus half and minus half. This is what? Superoxide. Superoxide means there are two oxygens combinedly with -1. -1 means on each oxygen you need to contribute -1 to two oxygens. Then resultant you will get minus of on each oxygens. This name is what? Superoxide. Oxygen will be having what? Three form. These three you need to know that: oxide, peroxide, superoxide. Next nitrogen. What will get here? N-3. N-3 name is what? Nitride. Next carbon. Carbon 4 means what? Carbide. So this is what? Carbide you have to take it. This carbon means negative charge. On the carbon is said to be carbide. Next oxygen in combined form. So on oxygen you can get many negative charge species, and nitrogen, let me give it nitrogen. This is what? NH2 minus. This is what? Amide. Okay, amide, sodium amide, NaNH2. Like that you can write the calcium amide. You can write many amides. Next oxygen. These are what? Free non-metallic oxides you can take. Next S minus 2 is what? Sulfide. Okay, sulfide. The next sulfide means what? On sulfur there will be a -2. Next nitrogen, N-3. This is what? Azide is the N3 minus 1. So this is azide. N-3 is what? Nitride. This is nitride. It's very, very important. One nitrogen having -3 charge. Name is what? Nitride. Here three nitrogens are having what? -1. This is what? Azide. This is azide. It's very, very important. Here charge is what? 1. Here charge is 1. Here charge is 3. But here one nitrogen, here 3 nitrogen. 3 nitrogen together they are having -1. This name is what? Azide. Sodium azide, barium azide, calcium azide. Later in once you enter Pu1, Pu2, then so you will get what? These all type of azide compounds. Azide compounds. Next other combined ions like NO2 minus. NO2 means nitrite, nitrite, nitrite. Then next NO3 minus, nitrate, nitrate, nitrite and nitrates. Don't confuse here. NO2 minus means nitrite, NO3 minus means nitrate. Okay, right. Then next sulfur, sulfite. This is sulfite, sulfite. Next SO4 minus 2. This is sulfate, sulfate. These here SO3 minus 2 and SO4 minus 2. Here charges are same, but only difference is oxygen. Here 3 oxygen, here 4 oxygens. This is sulfite, this is sulfate. Okay, so nitrite, nitrate, sulfite, sulfate. Next one more, thiosulfate. Thiosulfate means S2O3 minus 2. Its name is what? Thiosulfate. Thiosulfate is one very important compound in the photographic, that what, films. Okay, right. In that what if you want to develop the negative film, so you have to use this. This name is what? Hypo solution. Thiosulfate is said to be what? Hypo. Thiosulfate is said to be hypo. So to neutralize here -2, you can take sodium. Sodium thiosulfate is nothing but hypo. Its name is hypo. Hypo is one very important compound in so many applications like photographic, that what film developing. So in that also we will use this one, hypo, right. So these are what? Negative ions. There are few more negative ions. Let me continue. So please all students, you have to write please keep running notes. In that running notes you have to write cations and anions list, and you have to memorize all cations and anions. Then later definitely you will enjoy. Okay, definitely you will enjoy writing formula of any compound, means ionic compound, especially ionic compounds. Right, continuation of anions, continuation of anions, continuation of anions. With the duster it is not erasing. So if I use this cloth, then so it will be easy to erase. Right. So after thiosulfate is said to be hypo. Please remember the next continuation of anions, sulfur, nitrogen. Then next phosphorus. Right here, right, H2PO2. This is what? Dihydrogen hypophosphate. Dihydrogen hypophosphate. Right, next here you can take it HPO3 minus, you can take it, this is what? Phosphate. Phosphate means here you can take it dihydrogen hypophosphate and dihydrogen phosphate, dihydrogen phosphate. We can write monohydrogen also, HPO3 minus 2. So here same dihydrogen, monohydrogen, sorry, here only one hydrogen means monohydrogen phosphates, and next here without this you can write here you can't write it here. This is what monohydrogen. Next PO4 minus 3. This is what? Phosphate. Next here HPO2. HPO4 minus 2. This is monohydrogen phosphate, monohydrogen phosphate, and here H2PO4 is said to be -3. -1 here, -1 is a dihydrogen phosphates. Dihydrogen phosphate. These are what anions of phosphorus. Next, if phosphorus is having -3, is said to be phosphide. So like nitride, here there will be a phosphide. So this is a negative charge on phosphorus, -3 is phosphide. Next, with halogens, if you take with halogens, right, with halogen and oxo, with oxygen and halogen, right, let me take it here, ClO4 minus, this is what perchlorates and ClO3 minus, chlorate, sodium chlorates, potassium chlorates, sodium perchlorate, potassium perchlorates. This chlorate is the best compound to get oxygen. Artificially, if you want to get oxygen, you can use potassium chlorate. On decomposition of potassium chlorate, you will get oxygen. You can produce oxygen. Next, ClO2 minus 1. This is a chlorite, and ClO minus. This is what hypochlorites. Right here, very important. So this hypochlorites, nowadays we are using sodium hypochlorites. So to kill what? Coronavirus. So nowadays corona is one important, that means panic virus. To kill panic, this type of virus, we are using sodium hypochlorite. We are spraying sodium hypochlorite, that what solution. Right now, one interesting thing, let me explain why we are using sodium hypochlorite. Okay, why we are spraying sodium hypochlorites on surface of that what floor and other things. Right, what is the use here? Right, normally this sodium hypochlorites will undergo decomposition. Okay, so after spraying, after some time, it will undergo decomposition into what here? NaCl plus this nascent oxygen. It will give what? NaCl and nascent oxygen. This NaCl, nascent oxygen will kill the bacteria, virus and fungus. So it will suppress the growth of microbes. So growth of microbes, then it will, this nascent oxygen will combine with microbes which are harming, like a virus or bacteria or any type of microbes. Then this oxygen will enter into DNA of microbes and it will disturb the function of DNA. So that's why nowadays we are using sodium hypochlorite as a very good antimicrobe solution. So it's very important. You should know the mechanism. Right, not only here, in chemistry, whenever or wherever you are getting nascent oxygen, definitely it acts as a very good antimicrobial compound. So this is what you need to understand. Right, later in topics we will discuss many nascent oxygen compounds. Right, this is what chlorine. So please you need to concentrate here. With chlorine you will be getting what different perchlorates, chlorates, ClO4 minus 1, ClO3 minus 1, here ClO2 minus 1, ClO minus 1, hypochlorite. This is what here all are formula only little difference with oxygen, but name you are getting differently, but all are having what? -1 charge only. You need to notice charge and formula of the anion. Right, next instead of chlorine, so you can take the bromine or iodine. So what will you get here? Bromine. With bromine what will you get here? Perbromates. So what is the perbromate here? BrO4 minus. This is what perbromates and BrO3 minus. This is what bromates and BrO2 minus 1. This is here bromides and hypobromides. HOBr means BrO minus, hypobromite. Like this you will get with bromine. Same way with iodine also you will get. So with iodine, so iodine is what? Periodic, periodics, 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 and iodates, 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 like iodus. Next iodites, iodites, iodate, iodite, IO2 minus. Then like this you can write remaining, in place of chlorine you can put bromine and iodine. You will get what? Corresponding what? Oxo-halo anions you will get. Oxygen and halogen combination anions you will get it. Right. Then what about with fluorine? So fluorine will form only hypofluorous acid. Hypofluorous acid. You will get what with fluorine? Only HOF only you will get it. Right. Now one interesting thing here. Right, here why these halogens are forming means later in halogen family we will discuss very detailed why fluorine is not forming all oxo acids, and so what are the stable oxo, that what anions, these are oxo halogen anions. So later we will discuss, but just here you need to know the name of just anion, name of just anion. Okay, this is what halogen and oxygen anions. Next important, just we are here in basics we are discussing important anions and cations. After that combining you will get what important salts, which we are going to discuss, or which we are going to learn in PU1 and PU2 classes. Right. Next with oxygen, if I have it oxygen, oxalates, this is what oxalates, its name is what oxalates. Oxalate means what? COO minus, COO minus. This is what oxalates. So actually oxalates are one important that what calcium oxalate, okay, potassium oxalate, magnesium oxalate, like that you will be having calcium oxalate. So calcium oxalate is one that what important acid which will form the stones, okay, in the kidney. Okay, in kidney you will get the oxalate stones. This is oxalate. Next this is what acetates, organic anions. This is what acetate, sodium acetate, potassium acetate, and this is what vinegar anion, sodium acetate, potassium acetate, like this you will get acetate. And next formate, this is what formates, sodium formate, potassium formate, sodium formate and potassium formate. So this is a formate, means here if you put it H, then you will get formic acid. So what is already, you know that what is a formic acid? Formic acid is organic acid. So this acid present in ants, especially red ants. Okay, this formate means present in ants, present in ant. When ant is biting, means when there is a when there was a one means ant bite on our skin. So normally what you will feel after means after few seconds, definitely you will get some itching type and burning type sensation, you will get it. This is what due to formic acid. So when ant bite is there, so it will inject, means it will pass this formic acid into our blood. So automatically then you will get what burning and itching sense. So this is what formic acid. From the formic acid, if you remove H plus, you will get formates. You will get formate. Next benzoates. You know already benzene. This is what benzene. This is what benzoates. Benzoate. This sodium benzoate, potassium benzoate. Later in organic chemistry we will use this type of anions. This benzoate, sodium benzoate, so will be used to store pickles. Right, after making pickles like lemon pickle, tomato pickle, and there are many type of pickles in our home daily we are using. So in that pickle means what commercially. So when we are making commercial pickles to store long time, so this industrial peoples, okay, commercial peoples, they will add sodium benzoate. If you add sodium benzoate, and it will avoid the growth of fungus, on pickle. Okay, right, maybe you might have noticed, you would have noticed, I think most of the pickles means after 1 month or 1.5 months, so you can see the one type of growth of fungus. Okay, that what so to avoid that growth means you have to increase the lifespan of pickle. For that you can add sodium benzoate. So benzoate is what? One food storage material, food preservating compound, sodium benzoate. Okay, later we will discuss. Right, these are what carboxylic acid. Like this there are many carboxylic acids, oxalates, malanoates, glutarates, and succinate, pimylate. Like that, there are many organic dicarboxylic acids. Okay, so later, but this is what first member of dicarboxylic acid. This is what you need to, based on this you can write the many. Okay, many oxalates. Okay, oxalate is what? One type of dicarboxylate acid. Okay, anion -2. It will be what together? It is what? -2. Here -1, here -1, here also -1. These are what? Negative. Next, few more negative. Cn minus. What is Cn minus? Cyanide. Cn minus is what? Cyanide. Potassium cyanide. So very right. So that what? This is what? Highly poisonic compound. Sodium potassium cyanides. Right. Most of the cyanides will be used by the terrorists. Normally, when terrorist people will be caught by police peoples, that time normally they used to have, they used to swallow one type of that what? A small type of thing. That means from somewhere. Okay, they will open and they will swallow this one type of small bead type thing. So in that bead there will be cyanide. So in that there will be cyanide. So once you have it cyanide, then so within a fraction of seconds, definitely it causes death. So cyanide is very poisonous compound. This cyanide is what? A poisonous compound. Means poisonous. Sodium cyanide, potassium cyanide. So you have to avoid the cyanides. Right. So cyanide is very good poison. Cyanide, Cn minus. Next, cyanate. This is what? Cyanate, sodium cyanate, potassium cyanate. Okay, next, CNS. This is what? Thiocyanate. Thiocyanate, sodium thiocyanate. Later we'll use this cyanides. Okay, so cyanide, cyanate, thiocyanate. These are all similar names. Okay, cyanide, thio means cyanato, and thiocyanate. So these are what? Anions. Okay, so please concentrate these anions. Next, some complex anions. Right now, like D block elements. So D block elements also will form some type of anions. D block elements like chromium, manganese. Let me take it chromium. Cr2O7 -2. This name is what? Dichromates. And here CrO4 -2. This is chromates. Sodium chromates and sodium dichromate. Formulas are different. Please, you need to remember here. This is chromates. This is dichromates. Sodium dichromate, sodium chromate. So you will get like the formulas. So chromium anions. So chromium. Next, one more here. Permanganate. MnO4 minus means this is what? Permanganate. Potassium permanganate is one ionic solid. This is a permanganate, MnO4 minus. If you take it potassium, its name is potassium permanganate. If you take sodium, its name is sodium permanganate. So permanganates, chromates, dichromates are what? D block anions. Okay, but here charge will be on the oxygen only. Okay, charge will be on oxygen only. Next, vanadates. So vanadate also will be there. What is a vanadates? VO4 -3. This is the name is what? Vanadates. This is a vanadium oxo anion. Vanadates. This is what? Vanadates. So like this what? There are many anions. Okay, there are many anions. And next, a few organic anions like we can take it organic anions like CH3O-. This is what? Methoxide ion, sodium methoxide. Okay, sodium methoxide. This is what? Methoxide ion. Methoxide ion. Next, ethoxide. Ethoxide means what? CH3, CH2O. This is what? Ethoxide ion. There is a oxygen, means here negative charge on oxygen. Methoxide, sodium methoxide. These are what? Very good bases. So later we use this means sodium potassium oxides in organic reactions. They are act as a very good bases. Right? These are the names. Next, with other like benzene ring. On this, if you have the O-, this is what? Phenoxide. Sodium phenoxide, potassium phenoxide. You will get what? This type of anions. Sodium phenoxide and these are the oxides. Okay, oxides of organic means alcohol type of oxides. Okay, right. This is what simply you can write it here. This is RO minus. This name is what? Alkoxide. Alkoxide. This is what? Alkyl group with oxygen and a negative is said to be alkoxide. Right. So this is what naming of anions. Right. Firstly, what you have to do? Just you have to try to learn the all cations and anions. Once you know that, then now you can write the formula of any ionic compound. Right. Now after knowing anions, now we are going to write a formula of ionic compound. Right. So it will be very interesting. From 2 days means till now. So we had basics on writing ions and elements. After knowing the ions, then easily you can write the formula of any ionic compound. Right now its application is very, very important and interesting also. Please concentrate. Right. Now writing formula of ionic compounds. Right. What will be the method? Means as I taught earlier, how we can write the formula of any ionic compound from the criss-cross method. Now we are going to apply criss-cross method. What is the importance of criss-cross method? Means from that easily, once you know, after knowing cation and anion, you can write easily cation name and anion name. Easily you can write it. Now criss-cross method. Criss-cross method. It's very, very interesting and important. Right. What is the need of criss-cross? Right now let me give the writing formula of cation or anion. Right. Some students will write like for example, so write, don't make it notes, just please concentrate. If I want to write sodium chloride, what is the sodium chloride formula? Sodium chloride means one fellow will take what? Na plus, NaCl is the sodium chloride. Okay, nice. Next, magnesium chloride. Magnesium chloride means one student will write MgCl, that's it. Aluminium chloride, AlCl, that's it. Here aluminum is there, chlorine is there, aluminum chloride. Magnesium chloride, magnesium is there, chlorine is there, magnesium chloride. Sodium and chloride, sodium is there, chloride is there. Now is it correct? This only sodium chloride is correct, but magnesium chloride and aluminum chloride formulas are wrong. That means whatever you are pronouncing, if you write according to that, so it will be always wrong. Based on criss-cross method only, you have to write the resultant formula of the ionic compound. For that only, so you need to know the what would be the means what is the charge existing charge on cation and anion. Once you know that, definitely you can write the exact and correct formula of ionic compound. Okay, right. From the name writing compounds, it's not correct. So magnesium chloride means if you write this one is wrong. But what you have to write here, MgCl2. If you write MgCl2, it will be right. If you write AlCl3, then it will be right. Some students, okay, some intelligent students, they used to write what? Magnesium chloride means MgCl. Aluminum chloride means aluminums are chlorides are. Magnesium chloride means magnesiums are chlorines are. Magnesium chloride. This is what they used to write when teacher asked ionic compound formulas. Right, this what is wrong. Right, for that only we are following criss-cross method. Now let me start criss-cross method. Is very, very important method after knowing cations and anions. Okay, so please students, please concentrate more. Right, criss-cross method. So already you know that now I will be having here A plus Y and B minus X. Now I will be having, this is what cation, this is what cation, and this is what anion. This is what anion, negative charge. Then what will get here? You will get what? AX BY is the formula of ionic compound. This is what? Formulae of ionic compounds. Formula of ionic compound. This is what resultant formula of ionic compound. Right here, let me take it one note. When X value is equal to Y value, then always resultant formula. Then here resultant formula here when this is what the condition. This is what the condition. If X equal to Y, if X equal to Y, then what you can write here? X A plus X and B minus X. From this resultant formula will be AB only. Just you have to write here AB. AB means what? Just you have to write 1:1 ratio. Why? Because here whatever the negative charge which is equal to positive charge, whenever charge is same, then always formula will be what? 1:1. one cation combined with one anion, whatever the charge, when x equal to y, here plus 2 is there, here minus 2 is there, then what would be the resultant formula? EAB is the formula. You should not write A2B2. If you write A2B2, it will be wrong. Okay, this is what you need to remember. In other case, when x and y are not equal, then obviously you have to write this formula only. This is what the formula you can apply. Note is what? This one. Right. Now, application of crisscross formula. Now let me use the application of crisscross formula one by one. Right now, I will be having here sodium. I want to prepare sodium oxide. Sodium oxide means what? Na plus and O minus 2. This is what sodium oxide I want to prepare. So now sodium and oxide. Oxide means O minus 2. You know already minus 2. Now resultant formula. What you have to write? You have to take this one and you have to take crisscross. Here plus 1 will be the base of oxygen and here 2 is the base of sodium. Then what is the name of sodium oxide? Na2O. This is what? Sodium oxide. Sodium oxide is the name of sodium oxide. Next same sodium. Sodium, this is what? Plus 1 and O2 minus 2. Sodium peroxide. If I ask, if I take it, if I want to write sodium peroxide, then what would be the formula here? Sodium peroxide. What you can write it here? Sodium peroxide. Here crisscross. Here 2 and here 1. 1 you have to write. Then what is the resultant formula? Na2O. Na2O2 is the sodium peroxide. Next, I want to write here sodium superoxide. Sodium superoxide. Then what I would write here? NaO2. NaO2 is the sodium superoxide. Right? Please concentrate here. Sodium oxide means Na2O is the resultant formula. Sodium peroxide. This is what? Sodium peroxide is the second compound. And next here sodium superoxide. Sodium superoxide. So normally sodium will form only this water oxide only. Peroxides and superoxides are unstable, but potassium will form all three type of oxides. Okay, later stability we will think it. But here writing this sodium oxide, sodium peroxide, sodium superoxide is very, very important. Okay, is very, very important. Right. So here one student asked a question. Others power, cuprous and ferrous also sir. Darshan gaming sulfuric. Right. Now their question is, sir, these why hypochlorite, but this is no hydrogen in that formula. Right. After removal of hydrogen only we are getting what? Chlorides. So hydrogen will be eliminated in the form of H plus. For example, here hypochlorites. So here one student asked a question. So in the hypochlorites, why there is no hydrogen? For example, if I write it HOS here, to get anion, this is what H plus will be released. Then resultant what will get O, and here H plus will be eliminated. Now this name is what? Hypochlorite. So after elimination of hydrogen only you have to call it hypochlorites. Means here hydrogen is not there. This is anion form only you are taking. In place of H plus you can take the sodium. Sodium hypochlorite, potassium hypochlorite, like that you will get the compound. Okay, compound names you will get it. Right, next methanoic acid. Alright, so actually here methanoic acid and formic acid. This is what I gave formate. Now, right now you know the only common names. Methanoic acid, they are the IUPAC names. After knowing the naming of organic with one carbon, it is said to be meth. So OIC means carboxylic acid. So methanoic acid and this formate means methanoate is the another name. So this formate another name is what? Methanoate. Methanoate means anion form. This formate is the common name. Just here I wrote only formate. Why? Because here you don't know the naming of organic compound with a carbon number. If one carbon is there, methanoate, 2 carbons are there, ethanoate, 3 carbons are there, propanoate. That what? After knowing the organic compound naming, then you can write the IUPAC names. Formate and methanoate, both are same only. Right. Next, magnesium chloride and aluminum carbonates. What is this? I am not getting here their doubts. Okay, cuprous and ferrous also, sir. What for this? Question is not clear. Amma, whenever you are putting your doubts, whenever you are texting your doubt, please write properly. So whatever I taught, and based on that, if you have any doubt, sir, you said like this, but this is what my doubt. Like that, if you write it, I will get the clarity. Once I know once I have the clarity on your doubt, definitely I will give the explanation. So here I am not getting here cuprous and ferrous also, sir. What is the meaning of cuprous and ferrous? Right. Maybe you are asking maybe a difference. Cuprous means +1 oxidation state. Ferrous means what? +2 oxidation state. Iron with +2 means ferrous. Copper with +1 means cuprous. Okay, here As is there. Don't think it here. Cuprous means copper +2, not like that. Okay, don't think Amma. So it will be wrong. Next, Darshan Gaming asked sulfurous and sulfuric. So sulfurous and sulfuric, difference is what? Only oxygen. Already I give what? Sulfurous and sulfuric. So sulfuric acid, sulfurous acid means what here? SO3 -2 and SO4 -2. I give what? Sulfite. What I give naming of? This is sulfite, this is sulfate. So if you have H2SO3, this is sulfurous acid. This name is what? Sulfurous acid. If I remove 2 hydrogen, then -2 will be the charge. Next, from sulfuric acid means H2SO4. From this, if I remove 2 hydrogens, then you will be getting SO4 -2. These are the ion names. This is sulfite, this is sulfate. Sulfate you will be getting from sulfurous acid, and sulfate you are getting from the sulfuric acid. So this is what? Sulfurous and sulfuric are the acids. If you remove hydrogen, you will get corresponding anions. Sulfite, sulfate. Okay, here difference is, what is the difference means? Later, after knowing the oxidation state, here sulfur oxidation state will be +4, here sulfur oxidation state will be +6. In sulfuric acid, sulfur is +6, in sulfurous acid, sulfur is +4. This is another topic, knowing oxidation state. Okay, after knowing that, so you will get exactly, you can distinguish sulfite, sulfate. Here right now, SO3 -2 means sulfite, SO4 -2 means sulfate. Sulfate you will be getting from sulfuric acid, sulfite you are getting from sulfurous acid. I think your doubts clear. I think here one boy asked MgCl2 and Al2CO3. MgCl2 is magnesium chloride, formula is correct only, but Al2CO3. So Al2CO3 is aluminum carbonate, right? So you can write it here one more. Yes, you can write carbonate. Carbonate also one more anion you can write it. Carbonate is what? CO3 -2. So this is what? Carbonate, right? Please note down in the list of anions here carbonate also another anion. Carbonate also another anion. With carbonate also you get sodium carbonate, potassium carbonate, calcium carbonate. So like that there are many carbonates. Okay, calcium carbonate is the one important. Limestone. Limestone is the best example of carbonate anion. So like this what you will be having the anions, right? Now let me continue this. Writing formula of ionic compounds. Right, writing formula of ionic compounds. Now you know the cation and anion. From this you can create n number of examples. From this you can create n number of examples. Now we are going to write n number of salts. This is what with sodium, sodium oxide, sodium peroxide, sodium superoxide. So this is what one application. With oxide you can write it. Next, right. Next, second one, if I take it potassium hypochlorites. Potassium hypochlorites means K plus, what is hypochlorite? OCl minus. If you combine, then if you do the crisscross, whenever charge is 1, then 1:1 ratio only you will get it. It's very, very important. Next, here K plus and ClO2 minus. What do you get here? KClO2. And here K plus and ClO3 minus. Potassium chloride. You will get what? KClO3. Sorry, KClO3. You will get it. Next, K plus ClO4 minus. This is what? Perchlorate. KClO4. This is what? Perchlorate. This is potassium hypochlorite. This is potassium chloride, and this is hypochlorite. Okay, this is hypochlorite. This is just potassium hypochlorite, and this is chloride. This is potassium perchlorides. Okay, perchlorate. So these are what naming of different potassium and oxochlorine. That what anions. Next, if I write here barium oxide. So barium oxide. Barium is what? +2. you can write it, and oxide is what? Minus 2. Then what you can write here? BaO. BaO is the barium oxide. Here this is what, if I do crisscross, what I would write? If you write what? Ba2O2, then it will be wrong. As I said in the note, in note what I gave here, x value, when x value is equal to y, the resultant formula will be always 1:1 ratio. Here also barium plus 2 and oxygen minus 2. Here you will be having here, this is what x value, this is y value. Now x is equal to y. So whenever x equal to y, just you have to write it what? BaO only. You should not what? You should not write Ba2O2, you should not write it. Then it will be wrong. This is what formula is the correct. You should not write here Ba2O2. If you write this one, it's the wrong. Next, barium peroxide. Barium peroxide. Here, barium peroxide O2 minus 2. Now what you can write it here? Barium peroxide. Here one barium peroxide. Then if I write it what you can write here? BaO2. BaO2. 1:1 ratio. One ion and one ion. Then just you have to write BaO2 is the correct. Don't write it here like this. If you write it then this is what correct formula. This is what the barium peroxide. This is a barium oxide. First one is barium oxide. Here barium oxide. We are writing barium oxide. Barium oxide, and this is a barium peroxide. We are going to write barium peroxide. Barium peroxide. So barium peroxide, this one. If you write like this, it will be wrong, amma. O2, and then it will be wrong. If you write like this, barium peroxide formula is this one, not this one. If you write like this, it will be wrong. Next, okay, this is what barium oxide, barium peroxide. Next, fourth one. If I have aluminium plus 3, and I want to write sulfates, aluminium sulfate formula. Then here x and y values are different. Aluminium sulfate. What is the resultant formula of aluminium sulfate? Aluminium sulfate. I need aluminium sulfate. Aluminium sulfate. Aluminium plus 3 and sulfate is minus 3. Then if you do the crisscross, what you can write here? Aluminium, write Al2SO4 taken thrice. This is what the formula of aluminium sulfate. Aluminium sulfate. Aluminium sulfate. You should not write simply aluminium sulfate means. So some intelligent students will write what aluminium is what Al sir, sulfate is this one. This is what aluminium sulfate. If you write like this, it will be wrong. Okay. Then right. So some students normally they used to write without knowing the charge on the ions. They used to write aluminium sulfate means AlSO4. It will be wrong. Okay. Right. So to write aluminium means you should know what is the charge on aluminium plus 3 and sulfate is minus 2. If you do the crisscross, Al2SO4 taken thrice. There are 3 sulfates. This is what meaning 3 sulfates and 2 aluminium combined. So why? Because here always charge neutrality you have to maintain. So how many whatever the charge of cation, it must be equal to anion. Here what if I have it this is what 2 aluminiums and 3 sulfates. 2 into plus 3 total plus 6 charge, and here 3 into minus 2 total minus 6. Plus 6 and minus 6 combined, then you have to get neutral. That what you are getting in the neutralization means always charge equal negative and positive combines, resultant salt will be neutral state, no charge on the salt. That is what charge neutrality also you have to follow. It is very very important. So lastly I will give charge neutrality also. That this is example 4 with aluminium sulfates. Okay, aluminium sulfate, and you can take aluminium many examples. Many examples you can take it. Right. So here one student asked question aluminium carbonates. Right. Then what would be the aluminium carbonate here? Aluminium carbonate formula. Aluminium first we have to write aluminium, and carbonate is what? Minus 2. Then what you get here? If you write aluminium carbonate, here Al2CO3 taken thrice. This is what aluminium carbonate. Its name is what? Aluminium carbonates. Aluminium carbonate. But here we are not talking about stability. Whether this carbonate is it stable or not. We are not talking in this stability of ionic compounds. Just we are writing when you know the cation and anion, from the name only we are writing the suitable formula of the ionic compound. That what only we are writing. Not we are not talking about whether compound is stable or unstable. That what we are not going to discuss here. Right. This is what aluminium carbonate means. This is what the formula. Here crisscross. Okay. So 3 carbonates and aluminium. This is what resulted. Next, aluminium chloride. Aluminium chloride means what? Aluminium chloride. What will get? Aluminium chloride minus 1, and you will get what? AlCl3. This is what? Base of chlorine, and 3 chlorines here, 1 aluminium. AlCl3 is the formula. This is what formula you have to write it. Okay, you should not write simply Aluminum chloride means if you write this like this, it will be wrong. Same way here, aluminum carbonate. Aluminum carbonate means AlCO3. If you write, then it will be wrong. So this is what wrong method. So you should not write Al aluminum carbonate like this. If you write, it will be wrong. Like this, you can create a number of examples. Next, example 5, ferrous sulfate, ferric sulfate. So now my question is, here ferrous sulfate means iron plus 2, sulfate means no doubt sulfate ion. This is what ferrous sulfate. Ferrous means iron plus 2, sulfate means sulfate ion. If I combine, then what I get here? I have to get sulfate, ferrous sulfate I have to get. Ferrous sulfate means what? Here charge is what? Same. Whenever x and y values are same, then what you have to write it? You have to write the 1:1 ratio of ions. Then FeSO4 is the resultant formula. This is ferrous sulfate formula. Next, ferric sulfate. Ferric means iron plus 3 and sulfate. What is the formula of ferric sulfate? Ferric sulfate. Ferric sulfate. If I write ferric sulfate, what will you get, Amma? Here x and y values are not same, then they are different. Then what you can write here? Fe2SO4 taken thrice. This is what ferric sulfate. Ferric sulfate formula is like this. You should not write ferrous, ferric. Both are having different formula, not same. This is what you have to notice. Once you know the charges on cation and anion, then easily you can write the resultant formula of ionic compound. Then exactly you can write it. So without confusion you can write. Before you have to learn list of cations and list of anions. Once you know the list of cation and list of anion, writing any ionic compound will be very easy. So that is not no need to do retta. Okay, this no need to memorize all salts formula. Once you know the cation and anion, right? Like this, you can create hundreds of examples. So let me give the important examples in our PU1 and PU2 syllabus. What about the ionic compound which we are using? So let me give it ferrous, ferric. Next, calcium oxalate. Calcium oxalate. Calcium is what? Plus 2 and oxalate. Oxalate means COO minus calcium oxalate. So now if you take it here, oxalate is what, Amma? Here calcium plus 2 and oxalate together it is minus 2. The resultant what I will get here? Calcium, here C2O4 I will get it. This is what? Plus 2 and minus 2. This is what? Oxalate. Here another name is what? Another how we can write it here? Calcium plus 2. Oxalate means what? C2O4 minus 2. Here x value and y value both are 1:1 ratio. The resultant formula will be Ca. This is what? Calcium oxalates. Calcium oxalates. Calcium oxalates. Right, like this you can write. Okay, tomorrow I will continue writing ionic compound, salts, formulas. Few more we will write. And once you complete this the writing formula, then we will start periodic table. Tomorrow mostly I will complete in off session. I will complete in half an hour this writing formula, important salts, and later we will start the periodic table. So right, I hope all students, boys and girls, please take notes, and in notes you have to write everything, and you need to memorize all cations and anions, list of cations and anions. Once you know the cations and anions, then you will enjoy. With a smiley face you can say them and you can write them all formulas. Okay, so right, I hope today everything is fine. Right, so tomorrow I will continue this a few more salts formulas. Okay, thank you students. Okay, now.